p185, and it is a review of earlier in the school year, notebook page 25. So we are specifically looking at mixtures. And mixtures represent a physical blend of different types of particles that share the same container. And we subclassify mixtures based on their particle distribution. So classification is based on the distribution of the particles in the container. So as we move down the flow chart, our distribution could be described two very general ways. Either our sample will display equal distribution of the particles or an unequal distribution of the particles, where if it's an equal distribution, then the composition will be uniform. But if it's an unequal distribution, then we will see that the composition varies within the sample. We are able to notice we can visually see layers or differences. So we can visually see layers or differences. Whereas if we have an equal distribution, the composition is uniform, then we can't visually notice any differences. So here we go. The way that we handle these mixtures, okay? So we cannot filter a mixture where we have equal distribution or composition, that there are no differences like layers within the sample. In order to separate the components, we must allow time to evaporate, which is slow. So evaporate the sample, that is a slow process. We can speed up the same process by adding heat, which makes it happen at a much faster rate, or we could utilize the distillation, so we could distill the sample if it applied. Okay, so I'm not going to talk about this. Whereas if we have an unequal distribution, the composition varies, we can see visual layers, this would be the time that we could filter to separate the components. And a clue that you have unequal distribution of the particles in your mixture is because before you use it, you need to stir or shake before you put it into use. So now let's go back up. So when particle distribution is equal, the composition is uniform. So the sample seems to be exactly the same throughout. We refer to this as a homogeneous mixture. Whereas we have an unequal distribution, the composition varies. So it varies through the sample. Then we refer to this as a heterogeneous mixture. The last bit of notes here with this one is a very common word that pops up in our chemistry classes is the word solution. So if any sample is described as a solution, right away we know it's a homogeneous mixtures. And to take it a step further, for us in our class, we will also know that a substance is functioning as part of a solution, as a component in a homogeneous mixture, if we see it tagged with the phase aqueous.